Hey everyone, so I will be solving another paper here, and it is a Pure Maths 1 paper from the May June 2024 variant 11 section. And so let's begin. First question: express 3y square minus 12y minus 15 in the form this, where a and b are constants. So let's begin. 3y square minus 12y minus 15 is equal to 3. We will take the 3 common and we will write y square minus 4y minus 5, which is equal to 3. Inside the bracket we will do completing square. So y square minus 2 into y into 2 plus 2 squared minus 2 squared minus 5. So we've done completing square. Then 3. So this part is the completing square part, which is y minus 2 whole square. Then this part will come down as minus 4 minus 5, which is minus 9, and at the end it will become 3 y minus 2 whole squared minus 27. So that is part 1. Part B, hence find the exact solutions of the equation this. So what we will do is we'll convert this into something like this form. So what we'll do is 3x4 minus 12x square minus 15, and we will write this as equivalent to 3x square whole square minus 12x squared minus 15. Then we'll write let x square equal to y. So this would become 3y squared minus 12y. So 3y squared minus 15 equal to 0. And we also know that this is equivalent to 3y minus 2 whole squared minus 27 equal to 0, which is y minus 2 whole squared equal to 27 by 3. Replacing x square in place of y. So then we will have x square minus 2, which is root over of 27 by 3 is 9, or x square minus 2 is plus minus 3. So find the exact solutions. Let's see. X square minus 2 equal to 3 first, or x equal to plus minus root of 5. Again, x square minus 2 equal to minus 3, or x square equal to minus 1. This is not applicable as root cannot be negative, and we will write description to be you can either write not applicable or you can just write inadmissible. So that is question number 1. So question number 2. The diagram shows two curves. One curve has equation y equal to sin x, and the other curve has equation y equal to fx. In order to transform the curve y equal to sin x to the curve y equal to fx, the curve y equal to sin x is first reflected in the x-axis. Okay, so we know that sin x graphs move from this value to 1 minus 1 to 1, and this is transformed. So this one is our sin x graph, and this graph right here is our y equal to fx graph. So the conversion has become minus 5 to to sin x to 1. So the sin x graph in conversion to y equal to fx graph, this conversion has taken place. So we know that 0 level, we can see, I'm just giving you the things you need to know first, changes from 0 to 2. Okay, describe fully a sequence of 2 further transformations which are required. So one tip, always write stretch first, right? So we will give number 1 and we will write that stretch with scale factor equal to 3 in the y-axis, y direction. So why this is, so this part is, let's say like 2 units, but this part from here to here is 6 units. So 2 into 3 is 6. So this is the scale factor. And number 2 translation is, first let me write, I'm showing then, translation with vector of 0, -2. Why have I written this? So in this one the 0 level is 0, 0, but for this one the 0 level is at this point, -2. So as I've just told here, 0 level changes from 0 to -2. This is the exact thing that you don't use here. So translation has occurred and towards the negative y direction by a -2. So that is part A. Let's move to part B. Find fx in terms of x. Hence, so after reflection, y equal to sin x has become y equal to minus sin x because it is on the x-axis. So by our theory, the y value will be negative. After, so that is 1. 2. After stretch, y becomes -3 sin x. So in the y direction, so we will multiply 3 into the y, right? 3 into the y. So the third and last, after translation, right? After translation, y equal to -3 sin x. We place that here, -2, right, as this translation shows us. Therefore finally y equal to -3 sin x, -2. Always try to like divide the parts. Examiners like when you like give like details in this fashion. Okay, question 3a. The coefficient of x cube is given in the expansion is 160. Find the value of the constant a. So 3 plus ax to the power 6 is 3 to the power 6 plus, we'll first expand this, 6c1 3 to the power 5 ax plus, you have to be very accurate and skilled in this like techniques. So 3 cubed, and always use this method. This is probably the easiest. So x cubed, so what is the coefficient of x cubed? This one is the coefficient, and also a cube, 1a cube is there. So as per question, 6c3 into 3 cube into a cube is given to us as 160, or a cube, just divide 160 by this values, 63 into 27, this is 8 by 27, or a is cube root of 8 over 27, which is cube root of answer is a equal to 2 over 3. So find the value of constant a. We have found it to be 2 by 3. Hence find the coefficient of x cube in the expansion of this. So we will first write this, 3 plus ax whole 6 is what was that? So 3 to the power 6 is 729 plus 6c1 into 6c1 into 3 to the power 5, which is 1458. So 1458 ax plus 6c2 into 3 to the power 4. So 1215 a squared x squared plus 6c3 into 27, yes, which is 540 a cube x cube plus, so that is that. Then we'll multiply this with this, so 1458 ax plus 1215 a square x square plus 540 a cube x cube and 1 minus 2x. We need the coefficient of x cube only, so x cube is this one, so 1215 a squared into minus 2x plus 540 a cube into 1. This is only the x cube, 215 into minus 2 plus 540 which is x cube minus no, not really, not like this. So x cubed 1215 into 2 by 3 whole square into minus 2, we don't have to write the x there, plus 540 into 2 by 3 whole cube into 1. This should be x cube 215 into 2 divided 3 whole squared into minus 2 plus 540 into 2 divided 3 whole cube, which is minus 920. Therefore coefficient of x cube is minus 920. In this stage we can write using value of a. So that is question 3. Question 4. The equation of a curve is y equal to fx, where fx equal to 2x minus 1 root 3x minus 2 minus 2. The following points lie on the curve. Non-exact values have been given correct to 5 decimal places. So we can see the points here. Find the value of k. Given give your answer to 5 decimal places. So okay, so to place x equal to this in our main equation, and we find k. So k equal to 2 into 2.0001 minus 1 root of 3 into 2.0001 minus 2 minus 2. This gives us minus 1 into root 3 into 2.0001 minus 2 minus 2. This is 4.00063. Find the gradient of the chord AE. Give your answer correct to 4 decimal places. Okay, so gradient of AE is, this is E, this is A, so 4.63566 minus 4 by 2.1 minus 2. So this is 566 minus 4, 2.1 minus 2, which is 6.3566. This is the gradient. Part C. Deduce the value of f prime 2 using the values in the table. Okay, so for the value of here x equal to 2, we have to see which values over here are nearest to x equal to 2. I can see this 4 are nearest to x equal to 2, and this is slightly further. This is the most furthest, and this is quite far. So we have to make an estimation based on the values of y, which like the values of the gradient for which x values are nearest to 2. So here we can see that A, B, C, D. So gradient of AB is 6.25, AC is 6.2511, AD is 6.2608, and from E the values are far apart, so therefore f prime 2 is equal to 6.25. Question 5. Prove the identity. This is equivalent to this, so LHS, left hand side. So what can we break this down by? So let's do one thing here. Sine square x plus cos square x equal to 1, or minus cos square x equal to sine square x minus 1. So minus cos square x minus cos x by 1 plus cos x is equal to minus cos x and minus cos x. If I take minus cos x common, then it's 1 plus cos x, which is by 1 plus cos x. If we cancel this, we have minus cos x, and we have shown this. Part B, hence solve the equation this equal to 1 by 4. So now in this equation only the bottom part is a little different, which is half multiplied at front, and this part is same. So we'll write this as minus cos x, this is equal to 1 by 4, or minus cos x by 2 equal to 1 by 4. If you cut this, it's half, or minus or cos x equal to minus half. So cos is minus half, or cos x equal to minus cos, so we will do cos inverse 0.5, which is cos 60. So all sine tan cos. Cos is negative in these two quadrants, in the third and fourth quadrants, and they've set that the cycle goes on for 0 to 360. So we will do one entire rotation, so 1 point there, 1 point there. So x equal to 180 minus 60 and 180 plus 60. In this quadrant it is 180 minus 60, this quadrant it is 180 plus 60, or x equal to 120 degree and 240 degree. So yes, those are the answers.